The learning intention for this video is that we will understand and observe examples of precipitation reactions. A precipitation reaction is one in which two aqueous solutions are combined to form an insoluble solid. This solid is called the precipitate, and it is an insoluble ionic compound. I'm going to show you some examples of real precipitation reactions and also how we can determine if a precipitate is going to form. So here I have a spotting tile, and I've just put all the chemicals for each column in. So all of this column is iron sulfate. Then we have the iron 3 sulfate, copper sulfate, and sodium hydroxide. And we're going to observe what happens when I add sodium carbonate, barium chloride, and sodium sulfate to each of those solutions. Now, how do we know if a precipitate has formed? We are looking for a color change, and we're also looking for a solid forming and settling out of the solution. So as I add each solution, try and record whether a precipitate has formed and what color the precipitate is. There's actually a little mistake a bit later, and I thought about editing it out, but I've actually decided I'm going to leave it in and I'm going to use it as a learning opportunity. See if you can see it, and I'll point it out later in the video, but it's one of these reactions forms a precipitate and it shouldn't. See if you can pick which one it is. Okay, so let's see what happens when sodium carbonate is added to each of these. And now I'm adding the barium chloride. Now I'm adding sodium sulfate. Okay, so I'm just going to zoom in so you can see this a little bit better. You can see here that a precipitate has formed between the barium chloride and the sodium hydroxide, and actually there should not be a precipitate formed there. And so what's actually happened is there must have been some sort of contamination. And so I wanted to leave this in here because even though it shouldn't have happened, it really does demonstrate the importance of repeating your experiments to look out for things like that. So that contamination shouldn't have been there, but if I only did this experiment once, then I wouldn't know that. I would just assume that that was the normal thing for it to happen. Okay, so now for my favorite ones. In the classroom, this should be done as a demonstration only because of the lead nitrate. Students shouldn't be working with that. So this one here, we've got potassium iodide and lead nitrate. They're both colorless liquids before they react. Let's see what happens. Now, I've actually got the exact same reaction, but this time the precipitate forms and it makes it look like golden rain. So this is still the potassium iodide and lead nitrate, but what I actually did was I heated it so that we could redissolve the lead iodide back into solution. And as it precipitates out again, it looks like glitter. So here's the results of those reactions. Now, how do we know what the name of the precipitate is? So how do we know what has been formed and which one has actually formed the precipitate and which one is still in solution? So the answer is that these reactions are actually called double replacement reactions, as the metals essentially swap partners. So once we've worked out what the resulting products are, we can work out which one has formed the precipitate using our solubility rules. So let me go through an example together with you. I'm going to go through the first one that we actually tested on the spotting tile together. So here we've got sodium carbonate and iron 2 sulfate. And so we actually see that the metals swap partners. So this sodium here is actually going to partner up with the sulfate from the other solution. And the iron is going to partner up with the carbonate from the first solution. And so our products for this reaction are going to be sodium sulfate and iron carbonate. Now, how do we know which one of these is going to form the precipitate? Now we have what we call solubility rules. Here's a list of our solubility rules. Now there's always exceptions, and so that's why often you'll be given what the solubility rules are. And so for these, what we've got up here, we've got a carbonate and a sulfate. And so here we can see, here's our sulfate down here. All metal sulfates are going to be soluble except for these particular species. Now we don't have any of these in our reaction, and so that means that whatever has formed the sulfate is going to be soluble. And that means that this sodium sulfate up here is actually going to be aqueous in solution. Now let's just double check that, because let's have a look at what the carbonates form. Now here we've got our insoluble substances. So the following compounds are insoluble with the following exceptions. Now, an iron is not a group 1 metal. That means that anything with a carbonate, the iron carbonate is going to be insoluble, and therefore that is going to be what formed our precipitate in this particular reaction.